Namaste. Welcome you to the afternoon session as per the India and somewhere morning in Europe. And this is our first technical webinar on packaging connections of year 2021. So I'll just walk you through the way we will do it. We will start with first the technical presentation and then leave it open for the discussions at the end of it, about 10-15 minutes before. Prefilled syringes is a vast topic and not too much of information is available in an open domain. So we have tried to compile as much as possible, and this will be developing over the years because PFS is becoming more and more popular, especially when things like pandemic are happening. The importance of PFS is even higher. So now I will take you through the presentation one by one, and any questions, please note it down and then we'll talk about it. So today's topic is functional testing and qualification of prefilled syringes. Very, very important topic, especially when we are exporting or selling in regulated markets. Can you, looks like some people cannot see my screen. Is it? Okay, I think there was some problem, so but now it is. Okay. So especially when we are selling in the regulated markets, then the qualification of prefilled syringes becomes even more important for anything, and functional testing is critical anyway. So before we move forward, there's a small disclaimer that we don't own anything out of it. It is more of a compiling the information from the public domain, and the respective brands, wherever you will see some company names, they belong to the respective companies, and we don't have any direct relationship with it. It is for general educational purpose. So this is how we are planning to take you through on this journey of PFS. What is prefilled syringe? We will start from it, and then after giving you a small background about the prefilled syringes, which many of you may already know about it, but I think it is always better to start something and then move on. Prefilled syringes, as the basic definition, it's a single dose packet of parenteral drug to which a needle has been fixed by the manufacturer. And now we also get it where there is no needle, it comes with a luer lock, and where the healthcare professional will fix the needle based on the different thicknesses, so it can be both. They are becoming more and more important option for the delivery of the injectable drugs. And as you can see in the picture, it has basically the three parts to it. First is the plunger rod, center is a barrel, it could be glass or plastic. Then there's a tip, it could be with a needle or with a luer lock, and then on top of it there'll be a needle shield, there could be a tamper evident seal or whatever, depending on your needs and the end market. And there could be some more add-ons, but this is the basic. And benefits of prefilled syringes: it reduces the potential of microbial contamination, and dosing errors are minimized because this is pre-filled in a precision. and much more easy to use. The use of convenience, market benefits, because it also helps to reduce the cost of the therapy depending on the therapy. In some cases, it might turn out to be more expensive, but in general, it is much more cost effective. It helps to increase the lifespan of the drug, because if you have a drug in the vials and it's a multi-dose, and once you start using it, you have to use the complete drug. But in this case, when it is pre-filled, so it's fairly good to assume that the shelf life is, it's like a container, it's basically a container itself. And it also helps to reduce the wastage of the API, because directly the full drug is given and nothing is left over. So slowly, more and more markets are going for it. And then these are some of the pictures that you can see how the different components. This is the cover, barrel, needle, stopper, plunger rod, and this is how when it closes syringe with pre-stick needle. This is the one with the lure lock, where you can see the tip, slip tip and cap. I'm sure most of you know, maybe some people don't know, because there could be some students also into the picture, into the audiences. So I thought we will take you through. Another advantage with the PFS is you can really take it with the graduation marks, so that you don't have to worry how to measure it, and it can be pre-printed with the graduation mark, or you can have the graduation marks on the label and label out. And these are the glass syringes. Polymeric syringes, it could be COC, COP, PP, polycarbonate, the different materials which can be selected based on the drug. So there are mainly the two types, glass-based systems and plastic-based systems. When you come to glass-based system, it could be with the lure lock, means no needle, it has to be fitted later with the help of a connector, and a stick needle, where the needle is prefixed, so which is called a stick needle. Then plastic-based systems, which can have different plastics, COC, COP, PP, polycarbonate, or whatever, and it could also be both lure lock and a stick needle. Traditionally, the prefilled syringes barrels have been made from the glass tubing, and these glass tubings are formed into the shape by the application of heat, and then syringe manufacturer typically they buy the glass tubing, and then they buy the different elastomeric components like plungers, tip caps, needle shields, etc., from other companies, and they bring it together. So we could say that syringe manufacturers are typically the converters, and advantages of the glass-based systems. Healthcare practitioners, long history is using the glass syringes, so they're much more comfortable to them. It is just like that in a better way, because they don't have to worry about the measurement, and contamination is also reduced. They just take the needle shield out and then use it. Mostly prefilled syringes in the market are glass with elastomeric components, rubber stoppers. There are multiple proven suppliers. The drawbacks which we see now with the glass-based syringes are breakage, though it is much more controlled now, handling and everything, but glass itself is prone to breakage. So that is anything with the glass is always drawback is seen as a breakage. Glass dimensional variation is higher than the plastics. Potential surface reactivity, the stability could be concerned in some cases. We need to do more work for decontaminating them. And to make the movement of the plunger inside smooth, the silicone oil is applied, and the consistency application of silicone oil is always a challenge, so there could be inconsistency. See here, the oil can be applied in two ways. There could be oil siliconized syringes, the other one where there is a direct contact of the rubber to glass surface leads over a period of time they break the silicone film. And if you bake the silicone oil syringes, then that problem is solved. I think it will be better, much more clear in the upcoming picture. See here, in the first picture where you see this yellow line is the silicone oil applied in the traditional way, and the rubber is continuously hitting the stopper here. So over a period of storage, this film may break, and then there will be direct contact between rubber stopper and the wall of the PFS, which will create problems in breakout forces. So if you have a silicone oil baked, then that problem is almost eliminated, because then the silicone oil remains and the film does not break. You can see the red line, there is no breakage in between. And then in that case, when you compare to the breakout forces, you could see here it could change, but here, it's quite consistent. In glass, there is also a challenge of shifting in the pH, because typically the PFS are made from the type 1 glass, and which initially when the heat is being applied and the forming is being done, and during the cooling phase around 580 degree, sodium forms, and which remains in glass. So over a period of storage, sodium ions are released into the water or the diluent inside, which you can see here. Now the sodium ions are being released, and then there is a water hydroxy ions inside from the water, and then you have the pH changing, which leads to the change of the pH. So which may not be good for some drugs. When you move to plastic based, and that's the reason plastics are becoming more and more popular now. I understand that Japan is almost 50% or more with the plastic. And widely, which I mentioned before, COC, COP, PP, some other. Benefits: break resistance, much more bigger design flexibility because it's injection molded. So you have a better control on the dimensions. Surface reactivity is also minimized, and absorption of the drug is also less. And plastics are generally compatible with high or low pH equally. So as far as the shape is concerned, there is not too much of a difference. Basically, the shape is same, except that there could be some extra finger grip over here, which also makes it easier to dispense the drug, and especially when you are moving into the high viscosity drugs. Then other things are same. Of course, they will be based on the size of the syringe, same rubber stoppers and stoppers. So the major change is this particular barrel, which changes from glass to plastic. This is how it is. Components typically, So you could see barrel, glass or plastic, then rest of the things are in general same. Nothing changes of. So it's a good way of moving forward. Manufacturing of PFS, when you come talk about glass, is basically starts with the cutting of the glass tubing, then forming, and then needle assembly. In case it is a stick needle, if it is not a stick needle, then it's not required. Then it will move to washing, siliconization, and again, if it was a stick needle, the needle shield will be applied. If it was not a stick needle, then the lever lock cap will be applied, and then these will move for filling line. So filling of prefilled syringe is basically at the pharma company. So this is slightly better explanation of forming. And now next, forming steps explained better. Tip and flanges are sequentially formed by a local heating of the glass cut tube. Then it moves to the annealing because there are a lot of stress inside the glass when the forming is happening. It needs to be all evened out. And the right annealing is also important for the stable chemical profile. Otherwise, it could also lead to a lot of leachables. And the channel is created where the tungsten pin is commonly used to form the tip channel. That is from where the drug will come. So the residues of tungsten are quite common, and they're minimized during the formation step and through the washing and laminating. If drug is very, very sensitive to it. The pin can also be made of iridium or platinum. And residue controls are same like tungsten process. Higher concentration of pin-derived components may occur that are in the areas not in direct contact with the heat. Once formed, then syringe barrel has to go through the annealing oven to release all the stress in glass, and then the needle is fixed. And then the needle assembly process. Needle is basically mechanically placed onto the tip. An adhesive is applied, which is cured with the help of UV light. The reason to use the UV light exposure is very, very important, that it needs to achieve the adhesion almost instantly because it has to remain straight. If the needle is fixed at an angle, then it could create problems in many other processes. It has to be straight. Then syringe washing is done in a controlled environment with hot water for injection. And washing helps to reduce all residues, eliminate impurities. After the syringe drying, then it is lubricated with the medical grade silicone oil. There is a small video which could give you a fairly good idea how this is animation. You could see out of the syringe tube formed, now needle assembly, cleaning, drying, siliconization, needle shield application, and then going for the packing into the tub and net system. You see? So this is how one of the company, in general, the basic process, it's same for everyone, and sterile conditions. Of course, it has to go through the sterilization, but and inspection. This could be labeling, and now it goes into the. And now it goes to the basically. So don't be scared. This will not come only a picture. Ah, and this is this guy. So this picture is there on the YouTube, and link is there. And this is how they look into the final packaging stubbornness before filling. They come from syringe manufacturer to the pharma company. So you could see this is a closed top, sterile. Top thiavic lid is taken off. Inside is the next, and then inner lay film is taken, and this is the nest. This goes for the filling. Then, as you know, the syringe manufacturing consists mainly the 4 steps, and every step can generate or introduce some compounds which could be an area of concern for extractable and leachable. So this all needs to be tested. Silicon oil droplets and other particle impurities, which are seen through atomic absorption spectroscopy. Syringe and drug molecule compatibility. And after the siliconization, when barrels are put into the nest, they are visually inspected, and extractable and leachable measurements are done. This is after it goes to the pharma company, and they want to do the filling of the PFS at mainly the holding tank and the fillers having different multiple pumps with the different filling needles. Filling pumps could be different. There are so many different types available in the market: rotary piston, peristaltic pumps, membrane pumps, time pressure distal filling. So depending on the drug and the speed and the volume, one has to decide, and there are many companies. So typically a user company is responsible for selecting the filling system. PFS manufacturer will only supply you the PFS. It has nothing to do with the filling. Of course, they can make the recommendations based on your drug with their experience. Like size of the filling needles is based on the volume you want to fill. There could be 0.5 ml, 1 ml, 10 ml, and there's so many different volumes. Then, in case you got your product to be the oxygen sensitive, then there is also a possibility to put a nitrogen overlay, nitrogen percent, so that you reduce the impact of oxygen. So this is all part of the machine, filling machine. Filling of PFS, some more details. Like that, few major method. It could be through a mechanical vent tube method. It could be vacuum insertion, or it could be vacuum ball. So mainly the vacuum ball is used when the stoppers are received into the nested form. The typical practice in the market is that barrels come into a tub and nest form. Plungers can come in the bulk. The stoppers can also come into the bulk. And then filling and those things, stoppers are applied mechanically over a vibratory bowl, but they can also come pre-sterilized Of course, everything can come to sterilized, but they can also come to the nested form. And if the stoppers are coming into the nested form, then it is much easier and use the vacuum ball method. You don't have to use the insertion technique. Like here, when you do, you have to use vacuum insertion. In this case, there is an involvement of a transfer arm which actually picks it up and pushes it down all the way. I see there's some, and this is, it means it should have come maybe before the tubs are deleting is done. And when this PFS comes in, and then they're sent to the filling line, they do the filling. And after filling, then this whole operation is before the filling. And then after the filling, plunger stopper is inserted, which I was telling you before. And then tubs go for the re-nesting after compulsion of the filling. This is another video of filling machine. Again, from the internet, YouTube. So you can see the different clean rooms, the different areas, how these machines are there. And you also have this on the YouTube. So of course you all are from the pharma, you know, but patient don't know how complicated it is inside to bring them this drug and how much work goes behind it. And this is the clean room class C, which is semi-automatic. Debaggers, you can do automation. So now they cut it, and so only the sterile tray goes inside. And now and this will, so this is how it goes inside. And now the Tyvek top lid will be peeled off. You see, this is very, very important factor. And now inner lay taken off. And now comes to the filling and closing module. I'm not sure how many of you can hear the music behind it, but I think we figure it out. So normally these trays are based on ISO design and have typically 100 PFS into it. And these are the filling pumps which are working at the back. You see, these are from where the drug is going inside. And this is the PFS with layer lock, which I saw in the picture. And now comes a stopper sorting device. So you see, in this case, the stoppers are in a vibratory bowl. And now there are also systems where the stoppers can also come into the tray. You see, this is the first mechanically being put through the vent tube, which I was explaining you. And this is another method, vacuum, you see, put it, and that's it. You just put, and then it goes. And they just put it, and then you will see slowly through the vacuum, it creates a vacuum, and then it pulls it out. You can see the stopper sliding down. And now there will be a manual in process control. You can do automation or whatever, depending on whatever height you can put cameras. So this particular video was through manual inspection. In the unloading station. I was back into the same tub. And now this tub. You can stack it, use it. You can fix plunger rod now, take it for the labeling. And now I take you the. This is another one. I thought to bring you some videos so that you get a good feeling how the machines are working. Those of you who have not seen it or not using it or wants to get into it, especially nowadays when we don't have any exhibitions to see the machines running. That was manual process. This is automatic process. This is filling under vacuum. Mhm. These pumps are servo controlled, which you saw on the screen. Stopping under vacuum, but again, coming through the vibratory bowl. And this is the last video, which is again a very, very interesting thing. You would like to see this. And you can find all of them on the YouTube. We have no direct connection with any one of them, but we thought of showing you this because they really look good. This one seems to be very, very good compact tabletop kind of design. Can be typically used in the R&D. Like DIY, do it yourself. I think anybody could do it. Stoppers on plate means basically nested or through vibratory bowl. Both are possible here. And now we move to the, come back to our presentation. These are typically the custom markets for PFS. I think you know better than us, but they are used for highly specialized markets, high value, life-saving drugs. For qualification purpose, this thing, the way process starts, first we have to develop the PFS, look for the human factor studies, glass barrel, siliconization, cosmetic imperfections, extractable and leachable, plunger stopper suitability, container closure integrity, drug product compatibility. All these factors check together, complete the qualification and functional testing. So a developer has to define its purpose. Then based on its purpose, they will evaluate the supplier and then adhere to the regulatory needs. What are the regulatory requirements? Not every supplier might be meeting all the regulatory requirements. So based on the end use and which markets, supplier has to be chosen. For example, in the US, PFS is taken as a combination product regulated by US FDA, CDR, CBR, and then accordingly things have to be done. PFS has to survive up to the end of its shelf life based on for the drug because it's a combination product. So it has to go through container closure integrity test, and the goal is to treat the patient and obtaining market approval for a drug. So these are the three key important points. First, treating the patient. Based on that, the whole system has to be designed. Like administration of the drug could be self-administration with plunger rod, or it could be through an auto injector, or so we have to see how it's going to be used, what is going to be the duration of the injection. Accordingly, the PFS development will happen. Every user got to generate their own comprehensive data based on the drug and the markets they want to use, so that and the prescriptions they have from the required regulatory authorities. Of course, there's a compatibility of the drug has to be there with the filling system. It's a vent tube, vacuum under, and distal filling, which pumps, high viscosity, low viscosity, water-like, and then compatible assembly process, plunger rod insertion. Rod got to be strong enough so that it doesn't break while inserting. Regulatory considerations, manufacturing considerations have to follow combination as for the US FDA 21 CFR, CGMP. Then for human factor engineering, the human factors have to be analyzed through the summative validation study. Then it has also to be tested for the injection related anxiety, phobia. One has to transfer the learning, negative transfer of learning between different products within the company. For human factor study, the user environment is also critical. When you are doing the study, you have to see the lighting is proper, what is the temperature, and what are the auditory factors. whether somebody is hard of hearing or not, or whatever the issues, all that is part of it. Intended use, that how the user is going to use it. Is it going to be intramuscular, subcutaneous, on the arm, at the back, and depending all that, the human factor engineering is designed and the risk is assessed. Hazards have to be identified. Then the summative validation testing is done. This picture, you've seen it before in different ways, just to remind you, this is how the PFS is looking. Then these are some important definitions, though we are talking about the PFS all through. But just to remind, prefilled syringe, container system filled with injectable product ready for injection. Syringe barrel, cylindrical glass tube or plastic tube with front end and finger flange. Needle shield used to closure of the stick needles up. And if you're using the lure lock, then it's a different case. So this is sub-assembled, needle definition. I don't think I need to read it. Some more definition, plunger rod. Now, this is syringe barrel. These syringes are typically made as per ISO. So ISO has done a great job that they have made the recommendation, and the moment we are following ISO guidelines, so it's much easier to communicate and implement the things in different parts of the world. There's a lot of harmony. Otherwise, it will be a mess. So one can always refer ISO. Of course, you got to customize it depending on your drug, or if something has to be done from the branding, protection. But the key things can always be taken from the ISO guidelines, and most of the companies follow ISO guidelines as they're close to it. This is syringe barrel. ISOs for the lure lock also, there are ISO recommendations, ISO 594, 1, 2, then 8039, 1, apply. Then every aspect of the PFS is explained in the ISO, conical fitting. You will see further. You see, everything is how the glass wire, how the finger flange, for different volumes, 0.5, 1. In the one, there is long, there is short, 2 ml, 2.25, 3, 5, 10, 20. So ISO has done a good job. Again, some more drawings. For performance, hydrolytic resistance is tested, the different methods, titration, flame. Annealing is important part of the performance requirement. Lubrication, silicone lubrication is critical. Glide force is tested. When the silicone oil is applied, we have to make sure that it is homogeneous in application. So how do we find out? We can spray the aluminum oxide powder and see how it is sticking, or we can use optical methods where we can see. We can use flange breakage. Flange breakage is very, very important. So we can test it using the universal testing machine at different speeds. We can use syringe holder where the syringes are capped and they are made out of the peak in a particular dimension. The dimensions again recommended in the ISO. This is how it is. Flange breakage test. This is another when we want to do the compression of it. When we are preparing the samples, it is very, very important the samples are handled nicely, very delicately, because if the samples will go through the shock before testing, so we will not get the right results. And flange breakage resistance is tested into it's a force in Newton and distance in mm. So you could see when it breaks. Luer connection. We have to make sure the luer lock for the needles is strong, good, properly fitted, and luer syringes are fitted with a luer connector. Again, for testing, universal testing machine. So universal tester is very, very important part for the syringe business. Stick needle, then this is covered with the needle shield. In this case, minimizing injection site experiences or reactions. Needle material got to be compatible with the drug product. Very important part for the needle, geometry, lubrication, surfaces, smoothness, needle defects. Then the needle geometry is important part so that it does not hurt. Different diameters based on the different penetration length and so many different things. Needle defects. For high viscosity products, so you will notice that some of the things I'm going quite fast, but they're the standard but important points. So all these numbers that you could see. In case of high viscosity products, the time of injection may go up. Needle shield, very important part because it protects the needle mechanically, minimizes the risk of contamination from external environment, maintains the sharpness of the needle, very important. Otherwise, dispensing will not be good and it will hurt. Helps to prevent leakage or microbial ingress through the needle opening. These two, one could be rigid needle shield or soft, flexible needle shield, elastomer. It's easier to pull the soft one, but I think the rigid is better off from the point of view damage and compatible with the ethylene oxide. So it depends again on the end use what you're looking for. Siliconization, the silicone oil, polydimethyl siloxane. It should be medical grade and right viscosity. So the application of this depends on the final filling. For example, the vacuum plunger stopper placement may require more silicone near the flange than it's in the product area. Mechanical placement, more silicone need to on the plunger side. So it's important. How to test silicone application? You can spray the powder and you can see. Another method is reflectometry measurement, and you will basically reflect the light and see where it is reflecting more or less, and accordingly you know where there is more oil or less. You could take the section of the PFS, cut it half, look below the camera and see how good it is. Plunger stopper material could be different, and that has to be selected based on the formulation. And there are special stopper suppliers who have got various formulations. The properties of stoppers can change based on the fillers inside. This is something. Now we also get laminated stoppers with fluoropolymer or coated with the fluoropolymer, already cross-linked with the silicone oil. Different geometries of stoppers could be coated, not coated, laminated, not laminated. Sterilization, it can be radiation sterilized or UH sterilized. This is the way nesting looks. Testing stopper, the force required. This is a thumb pad, and it has to design in such a way when you're using it does not break. Extrusion behavior, force required to start the plunger moving. So initially the force will be more, and then it will be smooth, sustained once it breaks the initial pathway. Plunger stopper suitability has to be tested as per the ISO or ASTM. Container closure integrity, very, very important. It can be tested with the different methods to vacuum pressure decay, mass extraction, high voltage leak system, helium detection, dye ingress, microbial ingress. So dye ingress and microbial ingress are destructive methods. The first three are non-destructive. So we can use all of them or one of them depending, but and what is the level of leakage. So yeah, helium is one of the best because it gives you the smallest leakage possible, but of course expensive also. Dye ingress is a quick test, but it is not 100% kind of deterministic. Same thing microbial ingress, but these two are more of a which can be measured. So like this, it goes break loose force and use testing machines. Glide force, I have to go run fast, looks like they're running time. Needle penetration, different needles, penetration test. Tip removal, again there are attachments. Needle separation force, seal integrity testing, packaging of prefilled syringes can goes into tub and nesting form. Tyvek sheet, you have seen this. You can also use a rondo trays, polystyrene or PET. Function testing, cracks, presence of foreign material, damage accuracy, and again ISO is there everywhere to help you. Dye penetration test. So slowly we are coming to the end. These are some of the references which we used. And now this comes our end of the presentation. And I don't know how much time we are left, but we can probably take few questions. So I'll try. I will unmute you. I think you can unmute and speak up. I have. Can you? Okay. Yes, you have been unmuted. So if you want, any of you want to speak, then you can ask any question. You can unmute and ask.
Good afternoon, sir.
Hello,
Cafe here. Cafe here. Hello. Audible, sir? Hello. Hello.
I cannot hear you. I don't know. Hello. Hello.
Hello.
Can you hear me?
Yes, I'm
I
hearing.
don't know what is going on. You can hear me, but hello.
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 Sir,
Hello. Hello.
Yes, sir.
Now can you hear me?
Yes, yes.
Okay. I don't know what happened. Always some technical glitch. Okay, tell me.
hello, Cafe here, sir.
Hi, Kefi.
Good afternoon, sir. How are you, sir?
Very good.
Sir, actually, we need more information to how to find out the synchronization coating and all. This is briefly mentioned. This is a reflectometry process. But
Yeah.
sir, if we'll get more information about this to find out the thickness and all details, so it will be useful
Okay.
for us, sir.
Okay. So I will make a note of it and then we will get back to you.
Because thumb rule, I know कि if you stick the powder, some powder process or the put water inside, some meniscus formation will be there. That is synchronized vial and or non-synchronized vial. If you synchronized vial is there, if you put a powder, it will stick on the wall of the container. There's a glass vial or the syringes. But the
Mhm.
thickness is very important, sir, to find out how much thickness there and how distributed to all over the container on the surface.
Thickness is always a very tricky thing, but it can be found out if we have to find out on a with the help of high speed camera and through that. So we will have to see means with the help of the camera system it can be found out.
Okay.
Yeah.
Then Senthil.
Yes, Senthil.
Yes, sir. Addition to that, in that same siliconation related only.
Mhm.
So how we can find out equally distributed and how much amount the each barrel the present in, that also we can find out, no?
How much amount you can find out with the difference of the weight. You know, you can have when you have the consistent weight, you can see without and without with silicone oil. So you can remove the silicone oil and then do it. As far as the uniform thickness is concerned, so it is a combination of method. You will spray the aluminum oxide powder. Some places it will stick more, some places it will not stick more or less. Then you
Yeah,
see the difference. You see
Yes,
the
sir. We
yeah,
found
difference.
because
such type of thing.
but this is possible by weight method.
And you will need a sensitive balance like you do for the
Okay.
dose accuracy or something.
This will be mainly play with this BLGF study. So if not equal present, then it will be mm,
Yeah,
okay.
that's what I'm saying.
Okay,
This
sir.
is very tricky because this is a whole round thing. But at least you
Mm.
will get to know whether you have silicone oil everywhere or not. That is the most important thing. If you have silicone oil everywhere, then it is good. And if it is baked, then it is even better.
Okay.
But is it possible to check the silicone oil after baking?
Yes, I think after baking it is even easier. but then you will have to use the camera, the high resolution camera, because aluminum oxide may not work so well, powder.
Sir, after baking means when we receive any innovator sample or when we do the filling, is it possible to analyze the silicon content in that PFS? You are talking of the analyzing the silicon at the manufacturer end.
At the user end, when you buy it, then also it is possible by the same methods. So now the point is whether as a user we want to develop the labs to that level like a manufacturer. But the same test what manufacturer does, if we duplicate them at our end, then all this can be done.
But suppose we have received synchronized vial from the vendor, we will do the washing process at our end, at our facility. There are chances of goes off synchronization content from the container. Is chances
Then you know
or the
if you are
remains same?
doing the wash, if you are using the ready to fill, then only it will make sense. If you are going to the washing, then measuring the silicone oil is good for nothing. You know, the major silicone oil will go away. So that is the reason then people move to the siliconized or coated stoppers.
So you mean to say if you will use if you require the synchronized vial, so you ready to use, you need to buy from the manufacturer, not to wash
This is
here
my
at our
understanding.
end.
Yeah. Because if you apply silicone oil and after that you do the washing and cleaning, then silicone oil will go away. Na? It will not be remaining there.
But sir, cost wise high now. If you RTU, if you buy from the supplier.
It's always give and take. If you want the better
So my
quality and better control, then this is follow. If you wash it, then everything is gone.
Mhm.
And then you have to do the either you do the siliconization at your end. I think that is also possible.
Because
Or
we
you
got
use.
this query
Mhm.
internally, we got this query. If
I
you will
think then
buy
we'll have to.
from.
Then we should discuss it offline,
Mhm.
because I think we have the people from all over the world. So we will discuss it offline.
Okay, fine, sir.
So I think because we are already 10 minutes extra, so some people might have to go. So I would say thank you very much, and then see you whenever. And we will be doing more and more of this, and we look forward to your comments. Later, we'll get an email and you can make your comments, what improvements we can make. And if any of your colleagues who could not join and they still want to join, we have another session today, India time 8 o'clock. They could join there. Okay.
Thank you.
Okay, sir. Thank you so much, sir, for your
Thank you, sir.
presentation.
Thank you.
Thank you, sir.
Bye.
Sir.